to understand a clock problem, you have to understand first what a clock looks like. So make sure you can orient yourself and you're comfortable with looking at a non-digital clock. Okay, the second piece of info that you really need to understand is that a full circle, if I start at the 12 and I travel all the way back to the 12, I've traveled 360 degrees. So if I cut both sides of my equation in half, a full circle becomes a semicircle. A semicircle is now 180 degrees. So if I were to cut this in half, okay, and I were to travel from the 12 down to the 6, that's 180 degrees. Hello, straight angle. Cut both sides in half again, and the semicircle becomes a quarter circle, so let's make sure we see that. And the quarter circle now becomes 90 degrees. Hello, right angle. This time, cutting the quarter circle by 3. Why 3? Because it makes more sense. I have a 12 to 1 section, a 1 to 2 section, a 2 to 3 section. Cutting your 90 degrees in thirds, or trisecting it, I get 30 degrees. And why is this so important? What's the relevance of the 30 degrees on the diagram? Well, when I travel right here from 12 to 1, that's me traveling 30 degrees, or the hour hand or the minute hand travels 30 degrees to get from the 12 to the 1. To get from the 1 to 2, again, 30 degrees. To get from the 2 to the 3, 30 degrees. Okay, when you do clock problems, this 30 degrees is probably your most important number. All right, so let's go ahead and find the angle formed by the hands of the clock at 2 o'clock. Okay, so set yourself up a clock. Make sure you can draw the hour hand and the minute hand. So I know my big hand is at the 12. My little hand is going to be pointing at the 2. Okay, what do we want to do? We want to find the measure of this angle right here. Now I said this one was easy, and it is, because I can divide this up into two 30-degree sections. So from 12 to 1, we know that's 30 degrees, and then from 1 to 2, we know that's 30 degrees. So these are full 30-degree sections. I have 2 of them. So 2 times 30 degrees gets me 60 degrees. So one more quick example to make a point. What if I'm asking you to find 8 o'clock? Okay, do I go clockwise around this way, or do I take a look at this angle in here? Okay, and the answer is you always look at the hands of the clock and you find the acute angle. So I need to look at this angle. Do not do the obtuse. If you ever get a final answer bigger than 180, I can stop you right there and tell you you're wrong. Your answer is always going to be the smaller option. So splitting this into my 30-degree sections from 8 to 9, 9 to 10, 10 to 11, and 11 to 12, I see that I have 4 30-degree sections for a final answer of 120 degrees. So now we need to really get into the harder problems. What happens if it's not a nice, pretty 10 o'clock, 11 o'clock, 12 o'clock? What if it's not on the hour? Okay, in this example, I'm saying let's look at 10:05. So yes, your minute hand is exactly on the 1. Remember, it's 5, 10, 15, 20, 25, 30, and so on. So the minute hand's exactly on the 1. But here's where you have to be careful, because the hour hand does not go directly to the 10. It looks like it, but it is going to be slightly past it. Okay, for me, typically when I draw it, anytime it's past the 10, I don't want to get myself confused. So I typically will draw the hour hand at halfway between the 10 and 11. Now I know it's not really halfway, but my drawings are typically smaller than this, and that reminds me, look, it's not exactly at the 10, it's not exactly at the 11. It's somewhere in between them. So how are we going to tackle this? We're going to tackle this into the obvious, the full 30-degree sections, and then a partial section. Okay, so look what I've done here. I've marked my 2 full sections of 30. So I've got this little bit here that's not a full section, but once it gets from here to the 11, that's a full section from the 11 to 12. That's a full section from the 12 to 1. So I know I have 2 full sections right here and here. Now I have to take into account this part. I have to find a way to calculate the amount of degrees in this little wedge. Here's what I know about this pink part. I know it has to be less than 30 because it's not the full distance from 10 to 11. So therefore what I know is it is going to be some fraction of the 30 degrees. Okay, well what fraction? Figuring this part out is typically the hardest part of these problems, okay? And I'm not really sure where the struggle comes in, because when I look at this, I have two options. I have 5 minutes, okay, that have passed out of 60. So it is either going to be 5 out of 60, or it's going to be the remaining 55 out of 60. Okay, either way, I know it's 60 goes there. Why 60? Because there's 60 minutes in an hour. And this right here is how many minutes out of an hour have passed. So now I have to figure out, where is the squiggle? Is it on the side that the hour hand has already passed? Or is the squiggle on the side it has yet to pass? Okay, so pay attention here and see if we can make sense of this. This is the hour hand. When it leaves the 10, it travels to till it gets to 10:05, and then we're stopping it here. So it travels past the 10. This is 5/60ths of the way. That's how far it has passed 10. Because remember, in 1 hour, this hour hand only travels from the 10 to the 11. That's it. The minute hand goes all the way around, but the hour hand only travels from the 10 to 11. So leaving the 10 at 10:05, that means that the hour hand has traveled 5/60ths of its complete journey. Okay, it has yet to travel this distance. It stops here at 10:05. So it has yet to travel the 55/60th side. So we need to look at this wedge that's in my angle, because remember, again, where is my big overall angle? My big overall angle travels from this here to this here. So the wedge is included. The wedge is on the 55/60th side. So we go like that. And I'm going to simplify this math, and that's my answer. Okay, 2 times 30 got me 60. 55/60ths of 30. If I multiply those guys together, I get 27.5. Adding them together, I get 87.5 degrees is my final answer. Okay, let's look and see if that makes sense. So if the hour hand was exactly on the 10, it would be 1 section of 30, 2 sections of 30, 3 sections of 30, which would be 90 degrees. This has traveled a little past the 10, so my answer has to be a little less than 90. So 87.5, yeah, that's reasonable. All right, last example. Let's see if you're with me on this. So we're looking at 5:10. Again, the minute hand is going to be exactly at the 2. The hour hand is going to be past the 5, but not quite at the 6 yet. So I'm putting it kind of in the middle. Okay, we need to split up our clock. Split it up. I'm going to let you pause the video here if you want. Split your clock into your full 30-degree sections and figure out where your partial section is. So before I get into the hard part, let's make sure you're with me on what I've done. I have split my clock, hopefully you split yours too, into 3 full 30-degree sections. That's this part. But I still have this wedge. This wedge, remember, is a fraction of the 30. So what fraction? Well, I only have 2 options. I have to look here. Option 1 is it could be the 10 out of 60 side. Okay, option 2, well, what's left? 50 out of 60. So which one is it? The 10 out of 60 or the 50 out of 60? Well, if you look here, where is my wedge? My wedge, remember, is the partial 30-degree section included in my original angle. I'm trying to find the measure of this angle here. So we have 1, 2, 3 sections of 30, plus I shaded this before it got messy. Okay, that pink section right there, that's the wedge. That's not a full section of 30. So which one is it? If you guessed 10 out of 60, you are right. So now it is just number crunching. 3 sections of 30 gets me 90 degrees. 10/60ths of 30, remember you are multiplying those, gets me another 5. Adding them together, I get 95 degrees. Okay, looking at it, does that make sense? Well, sure. It's a little bit past 90 degrees, so I think 95 works beautifully.